f of x is equal to ln 2x minus 9, where x is greater than 9 over 2. G of x is equal to 2 ln x minus ln d, where x is greater than 0, and where d is a positive real number. We're going to do part B, which is to show that at the points of intersection, x squared minus 2dx plus 9d is equal to 0. So how do we find the points of intersection? Well, first we need to equate f of x to g of x. So f of x is equal to g of x, which means that ln 2x minus 9 must be equal to 2 ln x minus ln d. All right, now we're going to be using the product and quotient rules for logs. So ln 2x minus 9 would be equal to ln 2x minus 9, in this case, is going to be equal to ln x squared over d. Or we could also argue that ln d is equal to x squared over 2x minus 9. Therefore, if we cancel out both lns, we get that d is equal to x squared over 2x minus 9. Then, if we multiply both sides by 2x minus 9, we get that x squared is equal to 2dx minus 9d. And then if we subtract 2dx and add 9d to both sides, we get x squared minus 2dx plus 9d is equal to 0. And that is exactly what we were setting out to show. And so we have now shown that. Part II says to show that d squared minus 9d is greater than 0. So for this part, we're going to treat this as a quadratic, which it is, and find the determinant here, or sorry, the discriminant here. And so to find the discriminant, we have to use b squared minus 4ac in this situation to find that. Now in this case, a is equal to 1 because a is the coefficient for x squared, b is equal to the coefficient of x, which is negative 2d, and c is equal to the constant, which in this case is 9d, because keep in mind, if we go back to the instructions here, d is just a positive real number. D is not a variable like x is. So b squared, which is negative 2d squared, minus 4 times 1 times 9d, is equal to 4d squared minus 4 times 9d, which actually, let's just figure that out now. That's going to be minus 36d, minus 36d. And then if we factor out 4d, we get that this is equal to 4d times d minus 9. Now, in order for there to be two solutions, the discriminant must be greater than 0. Then we can divide by 4 on both sides to get that this means that d times d minus 9 must be greater than 0, which means that d squared minus 9d does indeed have to be greater than 0, so we've shown that too. All right, and the last part asks, what are the possible values of d? Well, here's the thing. If we go back to the factored version of this, which was d times d minus 9 is greater than 0, we already know that d must be a positive real number. So if d is a positive real number and the multiplication of d and d plus 9 must be greater than 0, that tells us that 9 must be strictly greater than, or sorry, D must be strictly greater than 9. Because let's say D is a positive real number, but the one that's less than 9, then D itself times D minus 9 would give us a negative times a positive, and that would give us a negative number, and a negative number would not be greater than 0. D also cannot be 9 itself, because if it was 9 itself, we would have 9 times 0 is greater than 0, and that's untrue. 9 times 0 is equal to 0, not greater than 0. Another way we can write this is we could also say that D must be a real number from 9, but not including 9, up to infinity. So this would be a second way of expressing the same thing.